Hello, my name is Victor and I want to welcome you to this video where I will explain our work entitled Student Connectivity Between Time Series Using Interactive Application. So the first question is, what is connectivity? So connectivity is a concept that might be treacherous for many graduate students. The main idea of connectivity seems to be obvious. Anyone can tell you if two elements are connected or not just looking at them. However, it is a broad term whose specific meaning depends on the field. We may consider that two people are connected if there is a physical link between them, for example, if they are hugging each other. But it could be an abstract connection. For example, they are also connected if they play tennis together or if they are relatives. In several scientific fields, the study of connectivity is based on time series. For each element, like the income of a company, we can acquire a signal that describes its activity along the time, with a different value for each observed time point. So for different companies, we have different signals, like the income of Ryanair and Netflix during the last 5 years. We can see here the effect of coronavirus, for example, during the last year. But time series are not restricted to econometrics. We can find examples in, for example, telecommunication systems, like the signals from our mobile phones, and also in our own biological system, like our heart or the firing rate of our neurons. So how can we measure connectivity between time series? There is an immense number of methods to analyze the connectivity time series, each one based on a specific feature of the signal and with a different result. For example, we might be interested in the connectivity between the number of pizzas ordered and the profits of the pizza shop. These signals are correlated, they covary, as if people order more pizzas, the company will earn more money in the same way. So we can measure this connectivity using the correlation metric. Also, the number of ordered pizzas depends on the day. For example, we will sell more pizzas during the weekend compared to the rest of the week. So the frequency of this signal is weekly, in this case depends on each week, and can be estimated using the coherence. The connectivity has also a certain delay. For example, our company will not receive the money instantaneously, but first you must order the pizza, then the pizza is delivered to you, and finally you pay the money. So there is a certain delay between ordering pizzas and earning money. And it's mandatory to understand the signal and the methodology that we are applying before making interpretations of the result. Using the same example, we may analyze the connectivity between the number of pizzas made, not ordered, and the profits. So we may well interpret that making a lot of pizzas will cause an increase on the benefits. But if people are not ordering them, you won't earn more money. Just a lot of kilograms after eating all those pizzas. In this case, one method to differentiate correlation from potential cause-effect relationships is granular causality. So the objective of the present work is to develop an interactive compute-based application that generates time series based on variables and parameters and analyze the connectivity between them using different methods. So the software generates 3 oscillatory signals where a specific frequency, phase, and noise can be tuned through a user-friendly interface with an immediate representation of the time series and also the frequency information, which is the power spectrum. The connectivity between these signals can also be parameterized, and the student can select the intensity of the link and also the directionality and the delay between the connectivity. So after selecting all the parameters, several connectivity metrics can be applied, including the correlation, the coherence, and the causality, with a visual representation of the results. Therefore, our application allows the comparison of dozens of different networks in a few minutes. Moreover, the software includes a help document with the theoretical basis of the connectivity and examples of parameters to test certain situations of interest. So that's all. Thanks again for watching this video until the end, and I hope you enjoy it. Goodbye.